All right, so today is just a review for your first exam, which is on Friday. Remember that it opens up at 9 a.m. You'll have a 15-hour window in which to complete it. The form of the review that I've got here is, well, I've got an old midterm from a couple of years ago. I've got my CS1 book here that is the suggested reading. It's not the required reading. Zybooks is auto-graded. And I've got a whole bunch of exercises from that. And we'll do as many of them as we want today, all right, in the 50 minutes that we have here. This one I've done now twice before, so forgive me if I go fast through it because I know it. I remember everything, but it's a body surface area exercise. So a strong hint here is that one of your exercises on Friday is going to be a simple basic I/O. Right, plug and chug, kind of the equivalent of a computer science plug and chug kind of thing, where you're given a formula or a series of formulas, you're given an input, and you have to produce output. Right, that was the first 2 weeks of this course. The next 2 weeks of this course were conditionals and loops, and so I've got the loop chapter here from my book, and we'll go ahead and do as many exercises as we want from that. But first, let's do this body surface area exercise. So this is an actual real application from medical students or whatever. They need to estimate dosage based on body surface area. Well, you can't get a real good accurate measurement on a body surface area because you'd have to, like measure the actual body. Instead, we've got these three formulas that are used that are empirically proven in practice to estimate it, given a patient's weight in kilograms and height in centimeters. The Du Bois formula here is just a simple square root of the product divided by 3600. The Haycock formula here incorporates a product of all of them with powers of it instead, which is basically the same thing here, but with a different coefficient, and these things here are slightly different. Instead of 1/2, you get 0.39 and 0.53. The Boyd formula here incorporates a natural logarithm in one of the exponents. Right? And then we're going to report the average of all three of these as the final statistic. They're all going to be very, very close because, of course, they are real formulas that are used in medicine. Right? So what we're going to do is we're going to build a program here that takes command line arguments and computes and reports the patient's BSA, body surface area, with respect to these three formulas and the average at the end down here. Right? Again, it's in kilograms and centimeters, as everything should be. Right? Everything should be metric. Right? So I'm going to go ahead and start out here. Well, here, let's go ahead and copy this demo to bsa.c. Right? And we'll edit that instead. Right? So the first thing that I should do, of course, is documentation. Right? Your author header. Some people are still not putting an author header in their hacks and are still losing a point or two every single one. That adds up, so make sure that you're doing that. Right? Me, the date, whatever the date is, but most importantly, the purpose of this program. Right? This program reads in a patient's, and we're not grading on spelling, but you should have good spelling. A patient's weight, and is it weight and height or height and weight? I forget. Weight and height. Weight and height in centimeters, weight is going to be in kilograms and centimeters respectively. Right? And computes their body surface area, which is in meters squared, square meters, right? Using three scientific formulas, right? And you can put those in the parentheses here, the Du Bois formula, the Haycock formula, and the Boyd formula, Boyd, not body, as well as their average. Right. So an anesthesiologist might be interested in this because they need to give a correct dosage based on body surface area for various medicines. I don't know. I'm not a doctor. I'm not that kind of a doctor. Right. All right. So if I'm reading these in as command line arguments, what does that mean? I'm going to be reading argv and argc. So I should definitely make sure that I'm getting enough command line arguments. If argc is not equal to 2, I'm expecting height and weight, right? But what else is a command line argument? The executable file name, right? So I expect 3 arguments, right? And if it's not 3, then I'll go ahead and print an error. Error. Provide the weight and height. There we go. And then we'll exit on them, because there's really nothing that you can do if they don't give you enough input. That's it. Right? Now let's actually read in the input. The weight will be a double, because as we've seen already from this one example, 76.5 kilograms, 175.25 centimeters, right? We're going to be accurate out to whatever, right? So I'll make both of these a double. And I'll make it a weight and height. Right? No need to encode like the weight in kilograms and the height in centimeters. You can do that if you want to. That's going a little bit too far for me, though. That's documented where? Up here. Right. All right. So is it argv sub 0, the first argument? No, that's the command line argument. So is it argv sub 1 by itself? That's the argument, but what do we have here? If I do that with both of these, what is the compiler going to tell me about this? gcc bsa.c.
You're not, you say argv, but it doesn't read it right.
Yep, what is it? There's an incompatible types here. On the left side, there's a double. On the right side, what is it? A char star, a string. Right, we haven't gotten there yet, but these are incompatible. How do I convert a string, an alphanumeric string, to a floating point number? A to F. Right? If this were an integer, I would use what? A to I. A to F on both of these. There. At this point, I have enough information to print out at least half of the output right here. This top part right here. Right? Cut and paste. I'll cut and paste that much. Document it and disagree. Document it in the variable. You don't have spacecraft crashing. Oh, okay. Well, you don't have crashing as long as you stay in metric, right? That's a reference to the 2 Mars landers that crashed for various bugs. One of them being one subsystem using English measures, which is absolutely wrong in most applications. Right? Only because of Reagan is this country still backwards on every other country in the in the world. Look it up. All right. There's our patient. Printf. Weight is going to be accurate out to 1 single decimal point, %1f. And I'll go ahead and end the line there and print out the weight. Same thing with the height. That I'll go ahead and go out to 2 decimals of accuracy here. 0.2f in centimeters, end the line, and height. Okay. What else is printed? Oh, and then the header of this table right here. Formula and then BSA in meters squared. So printf, formula, tab over or whatever, BSA in meters squared. You can make it look as pretty as you want. If you want to, you can go ahead and make some ASCII art here to separate things. It doesn't really matter. All we're looking at, formatting variations are perfectly fine. All we're looking at is the bottom line numbers here. Right? I am going to compile that and run it and see if it actually works so far to see that I'm reading in the input correctly. A.out, 76.5 and 75.25 centimeters. Right? It's looking like the output so far. But what if I do something like this? Is there anybody that is negative 175 centimeters tall?
No.
Not that it exists in this plane, right? Is there anybody that weighs negative 75 kilos? No. So, what should we be doing before we print this stuff out? Rudimentary error checking, right? If the weight is less than or equal to what? Well, what about 0? If a patient weighs 0, you're not going to give them any medication, right? But if a patient weighs 0, what's going to happen with this math?
0.
Well, 0 with about most of them, but
0 to the power of 0.
Natural log of 0
is undefined, right? Map it out. It's going to be negative infinity, right? So we're not going to allow that. Likewise, if the height, and you could do this as an else if, the height is negative or 0, right? Then we'll go ahead and printf an error. Height must be positive. Right, there we go. Get rid of that. And I'll go ahead and echo out another error up here, but with respect to weight. If we get past both of those, then we are assured that we're going to have some good output here. Although, let's go ahead and do that. And I still get my table. I get the error message, but I still get my table. What should I have done? Probably exit. Right? Now, as we're getting into functions here, you will never exit from a function. Right? That is not how you do proper error handling. I am only doing that here because we're still in the 5th week here, first 5 weeks of programming, and we're in the main. In the main, it's perfectly fine to exit if you get bad data. But in another function, right, if I gave -1 to square root, does it exit out of the program? No. It just results in not a number and an error. An error that then we can decide what to do with it. Right? As long as you are in this function, though, and you want to exit out of this, that's perfectly fine, as long as you're in the main. Okay? All right. Good. Let's make sure that this works now. Compile it. Run it. Good. Weight must be positive. All right. If the weight is positive but the height is negative, then it also quits. Great. And positive, positive. Once again, we've got good output here. If you want to align this stuff up, you can. I don't know, 5 and 5. Right? That way the decimal points will be all aligned. Right? And we'll do that in our table as well. Right? Okay. Whatever looks nice. All right. So start transcribing these formulas into C code. This one should be really easy. Square root of height times width divided by 3600. Right? So that was called the Du Bois formula. I'll go ahead and call it Du Bois. Right? And if you want to, you can postpend it with BSA, standing for body surface area. Some people would do this since it's an acronym. I like this because at least it's consistent, right, with lower camel casing. Right? If you don't care about that, you can leave that off entirely because the context is clear from your documentation. Link, here's the Du Bois formula. Read all about it. Right? Published in 1978, what, blah, 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 blah. Right? Who cares? BSA is equal to square root of height times weight divided by 3600. Let's think about this. Is it 1? Is there going to be an integer truncation issue here if I divide by an integer? The numerator is a double. Double divided by an integer? We're good. Right? Is there going to be an issue here with PEMDAS? Not really, but it's cleaner if you write it like this with the numerator on top. Right? It's cleaner. It is... you are advertising your intent. This thing is the numerator. I'm not relying on PEMDAS and left to right operations in order to tell you what the formula looks like. Right? Good. Second one was Haycock BSA is equal to this thing. And I'm going to repeat my mistake from 2 days ago because it's a good learning opportunity here. Do you ever arbitrarily cut and paste stuff, especially from a PDF? No. What it gets you into trouble, first of all? What? This stuff is being highlighted if you can see it really clearly. It's highlighted because it's not ASCII text. It is Unicode. Right? You can put emoji smileys into your code if the compiler is configured to do so. You shouldn't be doing that, though, right? You should only keep it as ASCII text. First of all, and it's also not going to compile in this case because that special X character is not the multiplication operator, right? But you also need to be careful because some people, I think on the error distance one, they were cutting and pasting from the PDF, and that had those, special degrees, right? And that ended up being in their code and causing problems. So don't cut and paste arbitrarily. It's also a security risk. You can, I could publish a website saying, hey, there's this cool Unix command line tool that you can use. All you have to do is run this command, right? And it looks innocuous, but I've used Unicode to hide a bunch of other commands that give me root access to your machine or something, right? And when you go and cut and paste, you're cut and pasting those hidden commands, and I've got now access. Right? That is an avenue of attack that's out there. Right? We can find some articles about it if you're interested in the additional reading. Right? But otherwise, be careful when you arbitrarily cut and paste code. And you are, by the way, in your own CS50. I mean, you're in your sandbox here. You do have absolute access. Who am I? I am Ubuntu. I am the operating system. I'm even in the sudoers group. Sudo is super user. Do the following, right? And it does whatever you want. Sudo rm rf. What does that do? Removes every single file on the entire thing without prompting me and ignore any protections that are there. I'm not doing that. Or that would be the end of today's presentation if I did that. Right. Okay. And then I'd have to go and reset it. Right. All right, H times. Oh, no, it's not H times, is it? It's H what? Power. So some programming languages let you do that. This is not one of them. Some programming languages let you do that. This is not one of them. To do a power in C, we do pow. And that's in the math library. So now when I compile, what am I going to have to do? Link in the math library. Let's clean this up and get it finished before I actually compile, though. Times, and then it's not h, it's height. And then this is going to be pow of weight raised to that power, and done. Right. Right. Double. Oops. Let's see. Boyd. Boyd BSA is equal to that thing right there. And I don't think I'm going to be able to cut and paste this. So yeah, my PDF previewer here won't let me do that. So I'm going to move this off to the side. You might be cut off on the live stream there. That's okay. Let me transcribe it really quick. 333 times pow of height raised to 0.3 times weight, pow of weight raised to, and then this long thing that I can copy here. Natural log of W. In math, that's ln, right? This ain't math. What is the natural log in C? It's just regular log, right? There is no log base 2. There's in the standard C math library. You can of course do that with a change of base formula like you did in lab 2. Right? Those all look good. So let's start printing them out. Printf. What is it? Du Bois. Right. Percent. We'll just go with F here. That's the default is 6 decimal places of accuracy, and the line. Du Bois BSA. Haycock. This thing. Body. Boyd. It should have been Boyd. There we go. There we go. And then, of course, their average. Line these up so that it looks nice and pretty. Right. Do I have an average yet?
Nope.
I neglected to do that. Double average. How do I? Yeah, go ahead. Oh, thank you. Good. Good eye. Oh, and good job, Microsoft here, for their VS Code highlighting non-ASCII text values. It should be minus. There we go. Yeah.
Log of weight, not log of
Thank you. All right. Good. Good code review here, folks. Actually, this is more like extreme programming. It was a fad a while ago where, well, it's basically what you do in your labs. It's peer programming. Extreme programming is where two people sit right next to each other and one person is doing all the work and the other is looking over their shoulder and saying, no, no, that, not that, not that, not that. Do this, 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 right? The driver, navigator kind of thing. It's not done in real life. Right? Plus, Boyd, it was BSA. Divided by 3.0, and you need to make sure that this is a proper numerator. PEMDAS does make a difference right there. Right? Lots of comments online. I don't know if it's just a talk back and forth or whatever, or if it's just internet random people. But if there's anything germane there, let me know, please. Right? All right. Looks good. Wall flag. You could even do the extra flag, but I don't think that there's anything in there. And let's see if it works. It was 76 and 175. And that's what it looks like there. I'll move it over here. Looks spot on. Excellent. Any questions on this? The only thing that I would say is that you should probably get rid of unused libraries there. That's cruft. Right? We didn't use the standard Boolean library, so you should get rid of it. We definitely use the other three. Right? Standard library is going to be brought in no matter what. We did some input-output, and we, of course, did some math. So all three of those are essential. Okay. We did that in 21 minutes with me talking about it. Take away me talking about it, add you reading it, and you could probably expect the same thing or something similar if you had taken this midterm 2 years ago. Right? The rest of the midterm is on arrays, which we have not covered yet, so close it out. Loops, however, are something that will be on the exam. There's a bunch of exercises here which are very, very similar to Lab 4. Print stuff out, using a for loop, use a while loop. It's not all that fun. I did this one on Thursday, if you want to watch the live stream of that one. I did this one this morning, if you want to watch the live stream of that one. Right? So let's do something else. And nope, that's too hard. That's too mathy. That one's just right. All right. So how do people come up with E? Well, it turns out that it's just a series. I don't know if it's a Taylor series or not, but it's a series, right? Where is it a Taylor series? Oh, okay, I don't know what it is, but it involves a factorial. I don't know. Do it. Nah. Oh, this is fun. Pi. Let's compute pi. Right? How did they compute it? Well, it's also this kind of series here, but it's a telescoping series. So 4 times 1, but then you subtract off 1/3. Then you add 1/5. Subtract off, this is why it's telescoping, it's going up and down, it's oscillating, right? And you're going by odd numbers, right? In fact, if you look at that first term there, 1, it's actually 1/1, right? Which simplifies to 1. And then you multiply 4 at the end. We obviously cannot do the infinite series there, the infinite oscillation. We have to have some stopping point because a computer has to have some stopping point. You could write a program like this to compute pi out to 1,000,000 digits if you wanted to. You would have to use some sort of multi-precision library to do that because doubles are only accurate out to 17 digits. What we'll do, however, is we'll say, I want it accurate out to 4 terms, and that's the second example there, where it actually computes pi to 2.8952 as an estimate of pi. If you did another term, then you'd have a little bit more accurate pi. Right? We're going to go ahead and parameterize this so that you could do it for 1 term, 4 terms, 8 terms, however many terms you want. Right? All right, so keep that in mind. Keep working. All right, so if I'm going to do that series, what do I need? An input. Okay, so I need, say, num terms. And we'll just go ahead and start out with the example that we have here. The one test case that we have right now is 4 terms, 1, 2, 3, 4. And we should expect about 2.852. All right. Then we'll go ahead and see and kick that up to 8 terms, 16 terms, whatever we need, and see if we get closer and closer to pi. All right. What else do I need? Well, if I'm going to be taking 1 minus 1/3 plus 1/5 minus 1/7, adding all these things up into one number, that's going to be a what? A sum, right? Or a total, whatever you want. Or call it what it is. Pi? Right? Or sum of pi or whatever. What do we want to call it? Sum? All right. Because it's not pi until you're done. Then it becomes pi. Right? Is it going to be an integer? No, certainly not. Double sum. Do I leave it like that? Careful. What value does sum have right now? Something, right? It could, 99 times out of 100, it'll be 0. Right? When you move from Ubuntu Linux over to SUSE Linux with a different configuration downstairs, potentially garbage. Right? So if you start your sum at 0, do it explicitly. You can do it 0.00. Always initialize your variables. Okay? So, sum. What kind of a loop do you want to do here? If I know that I'm going to do, say, 3 terms, or 4 terms, or 5 terms exactly. A while loop? Okay. We could do a while loop. Then we'll rewrite it as a for loop. Right? Whole exercise here. Right? What's my while going to be, though? How many times do you want to do this? I'll do it for 0, 1, 2, 3, 0, question mark, question mark. Right? While something is less than something, right? Do something. So let's go ahead and have I. Okay. Where should I start my I? Where's the first term here? What's changing over the course of these numbers? The denominator, right? It goes from 1, 3, 5, 7, 9, right? So where should I start it? 1. And what I'm going to do is I'm going to call it what it is. Denominator. Right? Now each execution of this while loop here, where is it going to go? It's going to go 1 to 3 to 5, etc. So I should go what? Denominator is equal to denominator plus 2. Is there a shorter way of doing that? Plus equals 2. Right? Just add 2 to it. Okay? Now, what's my term going to be? Here, I'll do it up here. Double term. The term is going to be 1 divided by 1, 1 divided by 3, 1 divided by 4. In other words, 1 divided by the denominator. That's why I called it denominator. Right? Is there going to be an integer truncation here? Anytime you look at division, the first question you should ask yourself, is there going to be an integer truncation issue here? Yes. Integer divided by an integer. How do we solve that problem? By making one of them not an integer. Right? You could do it with the other one if you wanted to. Doesn't matter. Okay. There's the term. I'm going to add the term. Let's find out. Sum is equal to sum plus the term. Right. I'll move the increment down there. Okay. At the very end, we'll go ahead and print out printf. Pi is about percent 2f, or we'll just go with we'll go out to several decimal places here, 10 decimal places, say. 15. Right. End the line, and pi. Now I need pi. Pi is equal to this sum, right, however many terms you wanted, times, don't forget that 4. Right? 4 times whatever the sum was. Okay? Let's compile this and see if it's right, or at least it compiles. I don't need to bring in the math library, of course, we're not done yet, because I'm not actually using the math library. I am the math library now, right? I'm computing pi, right? So, tell me, how many iterations do we go for here? Num terms. Okay, so while denominator is less than num terms, careful.
Nope.
Denominator is going 1, 3, 5, 7. It's skipping, right? So I probably want another separate variable here, and we'll simplify this. I would want to do a for loop from the beginning, but that's fine. All right. We'll go ahead and do this version. Then we'll refactor and do another version here. Right? While I is less than num terms, and then of course I go also I++. Right? Let's find out if it goes out to 4 terms. Remember, is 2.8952. Wrong. So we will eventually get to a tool called GDB, which is the GNU debugger, where we can walk through this line by line by line. You have access to a tool right now that I've shown you before, Python Tutor. If you wanted to cut and paste, not this one, Python Tutor. If you wanted to, you can go ahead and cut and paste this code and then walk through it line by line and see what's wrong. But does anybody see immediately what's wrong? Yeah. Yeah. I'm only adding 1 plus 1/3 plus 1/5 plus 1/7, right? It needs to be oscillating. The first term I add, the next term I subtract. Add, subtract, add, subtract, add, subtract. That means bringing in a conditional, right? So let's go with this. If sum condition, I will add it to the sum. If else, I will say sum is minus the term. Right? Okay. And you can shorthand these to plus equals, minus equals. I'm going to leave it like that until we figured out what this if statement should be. So let's walk through this. Initially, I is 0. We should be doing this. The next iteration, I is 1, and we should be doing this. The next iteration, I is 2, and we should be doing this. The next iteration, I is 3, and we should be doing this. See a pattern? If it's even, do this. If odd, do this. How do I determine if something is even? Yeah.
You can take 2 for remainder is equal to 0.
And how do I find the remainder?
Would be %2.
I mod 2 or %2. And if the remainder is 0, then it's even. And I don't have to check if it's odd, because if it ain't even, it's odd. Right? 0 is even. Right? Let's see if that cleaned it up. 28952 and change. Spot on. Can we improve that to closer to this? I don't think that this has a very good convergence properties. So, yeah. 8 terms, and we're still not really that close, right? 156 terms? We're probably going to lose precision at that point, but we're not even close.
Well, that's very close.
Well, it depends on what your measure of close is. I would say it needs to be at least 4 decimals of accuracy. I don't know. Let's add an order of magnitude here. So do this, or just write down 3.14159 as a constant. There we go. 1415. We're still not there. 1,000 more. Yeah. A question? Nope. Did anybody have a question? Okay. I don't know. I'm curious. 1 million. 14159. I don't know the rest of the numbers, so don't tell me. But you had to do 1 million things just to get it accurate out to that? Okay. 2 million, 10 million, whatever. Suggest some cleanup here. I've got a lot of variables. All right? Let me kick it down here to 4. All right? Is there a way that we can condense some of these variables? Is there a way that we could rewrite this so that it's not a while loop, it's instead a for loop instead? Well, one immediate way that we can do that is what? For int I is that I is less than number terms, I++. That gets rid of 2 lines of code. Right? Is there a way that we can incorporate I into the denominator so that we don't have to add 2 each time? Probably. I'll leave that as an exercise, though. Is there a way that we could... Now, I would say that a for loop in this case, if you're going to go with a specific number of terms, is the way to go, the natural way to go. But another way that you could go is, instead of number of terms, is it close enough? Right? In other words, is it like we've been building in a tolerance of delta or epsilon or something into our error checking, right? Into our unit test that we did last week, or on Monday, I guess. You could build in a tolerance of this. Keep going while you're still far away. While you're still far away from pi, while you're off by 5 decimals of accuracy or something, do another iteration. Do another iteration until you're close enough. Once you're close enough, then stop. That would be more appropriate for a while loop, definitely. It all depends on what you're doing. But of course, this is a toy example. You don't have to compute pi. All right? You just use a constant in the math library. Other stuff here, you can do sine with the Taylor series. You can do pi with Machen's formula, which is arctan, right? Where arctan is another Taylor series, right? You can do arithmetic geometry, all this math. Derivatives, integrals, don't worry about it. This one's a cool one, but I won't do it because it's too complex to do in 10 minutes here. But these are the kinds of exercises you can find in my book, where you have this bounding box. And now think about a ball that you send off in a certain direction, in a certain vector. And then it infinitely bounces off all of these walls, right? You have to compute each one of these points at which it bounces off, and then the reflection, the perfect reflection of bouncing off that wall. If it travels, say, 5 meters, where does it end up in this perfect bounding box, right? It doesn't slow down, right? Think about that. And that's going to be a lot more. Here's the actual output here. Those are all the points. Right? These are some kind of fun exercises that you can do as extra if you want to. Primality testing. Computing pi randomly by throwing darts into a unit box here, and if they land within the circle here, then you add that to pi. If they land outside, you take it away from pi, and you can estimate pi by randomly selecting points. Drawing regular polygons, right? All very, very math-oriented. Closest points, right? Another Taylor series for natural log, right? Kind of see a pattern here. I've given these as exercises over the years. Computing a square root using an EDSAC method. That's one of the first actual computers. I think it was an electronic computer. What is it? Yeah, we can look up a picture of the EDSAC. It used to be that there was a lot of computing history in a course like this, but nobody cares anymore. There it is. Somebody, I believe that it was the first one of the first electronic computers, and they had to develop a way to compute the square root, so they had to come up with an algorithm for it. All right. Your exam will open up at 9 a.m. on Canvas. There's a handout. There's a PDF just like we've been looking at here. And you'll have some instructions on how to do it. You'll do it exactly like a hack, in that you will write the program, you will submit it to the web hand-in. The grader is already set up and ready to go. You can grade yourself as many times as you want until the due date, which is 11:59 p.m. that Friday. You can hand it in, re-hand it in until it's perfect. Right? Do not start at 11 or 11:30. You have a 15-hour window. Right? Start somewhere reasonable in that window. Start during this class time, for example. But you have as many times as you want to fix issues, hand it in, and make sure that everything works. The one thing that is different than anything else that you've done in this course is that you have to work alone. Right? There is no collaboration allowed with anybody else inside or outside the class. Talk with each other about the test after, or the exam, After it's concluded, all you want, right? Post on Piazza about it, all you want. But prior to the exam, no talking. Right? And again, we will be running our plagiarism software against it, so please don't be tempted. Right? All right. Any questions? Yeah. Well, Canvas. Come on. Come on. At least I had my phone right here. You actually don't need to log in to get to Canvas. It's a public course, but so under recommended reading, Computer Science 1. That's the textbook I wrote that I used not long ago, but prior to Zybooks, and then we introduced Zybooks in order because nobody read anything, and now they read stuff because it's graded, right? So you can go ahead and download the entire PDF there. It's a Creative Commons license. And all of the exercises that we were looking at were in there. Not the BSA one, but that's just because I haven't added it to the book yet. All right. Good luck.